Hey everyone, welcome to your free GMAT prep hour. My name is Reed Arnold. It is July 19th, 2020. Welcome if you are watching live. Thanks for being here. If you're watching recording on YouTube, glad to have you as well. If you're looking for other free options for GMAT prep, you can try the first class of any of our GMAT courses for free. That is 1/9 of the entire course, 11% that you get no questions asked. Try it out, see if you like the course, like the material, like the teacher, what have you. As I always say in these sessions here, the first lesson of our GMAT course covers some very big stuff, particularly data sufficiency and also how the test works. And so it's a really good introduction for anyone who's starting their study process, and it's totally free. So I think it's a good resource to take advantage of, even if you don't want to pay us money. Don't tell my bosses I told you that. You can also try our Interact course, our video course, for free. You have a trial version of that. See if you like how that works. It's a really neat software. It adapts to you as you are working, much like the test does. So you get a question right, it'll take you to a harder question. You get a question wrong, it'll take you to an easier question. Really neat program, has won several education awards there. All right. Today's lesson, I'm always looking for some new lesson for these free GMAT prep hours. I try not to be too plain Jane in them. And so the lesson I've landed on today is common but uncommonly mentioned GMAT mistakes. And what I mean by that is there are common GMAT mistakes that we could talk about that are certainly worth knowing and looking for and correcting. You know, I read questions too quickly and I overlook information. I answer the right, I do good work and answer the wrong question. I lose a minus sign when I'm doing arithmetic, right? All that stuff is important and worth digging into and finding the habits that are going to save you from making those silly mistakes, or conceptual mistakes, whatever they are. But I wanted to talk today about things that I see with some frequency, but that probably won't show up in a GMAT manual or a blog post, or might not have even specified it before. But it's the kind of thing where, and these aren't necessarily the most common GMAT mistakes, but they are mistakes I see pop up, not every time, but often in certain situations. When a certain situation, a certain question type comes up, I often see students make this mistake with this kind of question. And so I wanted to go through today and just do some problems and specify what these are so that you can look for them in your own preparation, and also start to see what the GMAT is testing. Because a lot of these little mistakes that are problem specific are versions of a bigger skill or bigger skills that the GMAT is testing overall. All right, so that's the idea of today's lesson. If there are no questions, we'll go ahead and just dive right in. I'm going to pull up two problems here. I'll give you all 2.5, 3 minutes for them, which is a little bit faster than GMAT pace, but these things always go so fast. I want to make sure we get through enough of the lesson that it feels like I've managed my time well. So 2.5, 3 minutes. Take your best stab, and we will discuss. as you come to an answer here, go ahead and type in the chat what you pick. If so, say if you like D and E, say D and E. Read the answer choices. Let's see where we're falling here. All right, let's talk this one out. So I'm getting, I'd say the gravity of answers is something like A and E. Okay. Which tells me that a lot of us made the mistake. These questions are meant to emphasize on one of these problems, although not on the other. Although I did have some people, I did have some A's and A's. And if you answered A, you fell for the trap that this question is kind of setting on either answer. Okay. And so the purpose of these questions is to talk about negative variables and what they are and how to think about them. Okay. And this is super, super common. A lot of questions deal with the negative variable. And I want to really, let's think about this for a second, what a negative variable really means. We're told here x is negative. So I have this integer x, and it is negative. And so it feels like, okay, well, there are a few ways to think about this, right? A negative x becomes positive, right? Because negative negatives, like negative 5, becomes 5. And so this negative of a negative x becomes a positive, and then x over y, absolute value, is positive. So we have like double positive happening. So I want to choose x over y, one only. Okay. Similar down here, like, well, x is negative, and I have 5 minus x equals some number a. Well, if I subtract a negative, I turn it positive, right? 5 plus x, just like if I have 5 minus negative 5, that becomes 5 plus 5. And so you say, okay, well, 5 minus x, if x is negative, becomes 5 plus x. That would be the trap answer in number 2 here. Both of these mistakes are similar. Okay, so let's just think about this for a second. This is the absolute value of some number, negative x over y. The fact is that that can't be negative. Whatever that absolute value is, it's not going to be negative, and it's not going to be 0 either, because these values are not 0. So it's going to be a positive number. Well, what do we know about x over y? X is negative, y is positive. This thing is negative. It's less than 0. So 1 can't be in the answer choice, which any answers that have 1 have to be gone. But this appearance of the absolute value of negative x over y when x is negative, it really screams, oh, let's just cancel out the negatives, they go away. That's not quite what's going on here, because when we say x is negative, where is the negative? Like, if negative 5 is negative, I see this negative. I see it, it's right there. And so it looks like two things. This looks like negative 5. And in some ways, that's correct. It is two things. This is negative 1 times 5. I can break negative 5 into those two things. But it's also one thing. It's also just negative 5. Okay? In the same way that 10 is one thing, but it's also two things, 2 times 5, or 7 plus 3, or any other expression that equals 10. But x looks like one thing. So the negative is inside of this variable. I don't know what it's, I could say x equals negative a, some positive integer a, but the negative sign is part of x. And so it doesn't just cancel out. It's still here. It's still inside this x. It's still inside this x. So when I take the negation of that, when I take the negation of a variable that has a negative inside it, that becomes positive. And so this is the absolute value of negative x over y. It looks negative, but since there's still a negative inside x, it actually becomes positive. Same thing down here. That negative in the denominator makes it look like y is negative, but that negative sign up top that's not seen but is inside of x cancels out. And so this is also greater than 0, and it is also the absolute value of negative x over y. And you can pick numbers, you can say x is -4. This is the easiest way to do both of these questions, quite frankly, and y is 2. Well, then the absolute value of -4 over 2 is going to be the absolute value of 2, which is 2. Which of these equal 2? Well, this would equal -4 over 2. That equals -2. That's out. This one equals -4 over 2. That's going to equal 2. This one's going to equal -4 over -2. That's going to equal 2. So the answer is actually E. But I had a boatload of A's here, so I want to make sure we're clear on this. Are there any questions about number 1 that I can clarify for you? Do you see the trap that's laid here? James, we'll talk about number 2 here in a moment. It's a similar trap. We didn't fall for it as much, which is good. But I want to make sure we're clear on number 1, what's going on. When a variable is negative, the minus sign is inside the variable. You can't just break it apart. It's always in that variable. Okay. Same thing down here. Yeah, x is negative, right? It's true x is negative, but the minus sign is inside x. So I can't just turn 5 minus x into 5 plus x. That's not the same thing, because the minus sign is still inside that x. If you were to do it like 5 minus -5, if that were 5, if my x was -5, notice I can turn this into 5 plus 5, that's true. But this 5 is not the same as this -5. And so I can't say that this is 5 plus x. That doesn't work. These do not turn into each other. So I have a question in the second answer to question 1. I think that's this one. Would the negative sign make y negative? No, so that negative sign in front of the fraction just applies to the whole fraction. In fact, it really doesn't matter. Negative x over y equals negative x over y equals x over negative y. These are all the same. But since that x is negative in every situation, it turns the whole fraction positive. Okay. So yes, I can turn 5 minus -5 into 5 plus 5, that's true, but that 5 is not the same thing as this -5. But x is the same thing as x. So I can't just turn the negative x into plus x because x is negative. That's not how it works. The negative sign is still lurking within that variable. Okay. The answer choice here is E. And again, it's probably easiest to pick numbers here. Let's say x is negative, so let's say x is -2. So 5 minus -2 is 7, so 7 is A and B since they are the same. So I want something that ends up with, where I plug in B7 and x -2. The only one that works is going to be this one. This is 5 plus -2, that's not 7. This is 5 minus the absolute value of -2. That's going to be 3. That's not 7. This is -2 minus 5. That's -7. This is 5 plus -2 absolute value. That's 3. The only one that fits is E. Okay. So when you have negative variables, keep the negative as part of the variable. It's still there. You can't do the aesthetic cancellation like you can with numbers. The answer to the first question is E. These two are equal and they are both the same. Okay, so that's a super common issue I see when certain questions pop up. Just keep an eye out for it. Take a look here. Take a minute to answer this data sufficiency question. And I'll write out a reminder of what these answer choices are. So yeah, it's about a minute. I know you have 2 minutes typically for GMAT questions, but for the sake of time, we're going to move through this one a little quick. So I'm seeing a lot of D's and E's popping up, and that's good because that's exactly what this lesson is for. All right, if you chose D or you chose E, you actually, depending on which one you did, fell for a certain trap the GMAT sets here. So what we're dealing with now is the positive and negatives of exponents and radicals. Okay, if you chose D, it's probably because you said, well, x squared is 64, and the square root of 64 is 8, so x is 8. Okay. The problem is that we never were told x is positive. And if x squared is 64, x could be 8, or x could be -8. -8 squared is also 64. So if you chose D, you didn't consider, I suspect, the negative possibilities in statement 1. And it's always worth remembering, and if you have, a squared equals some number, whatever, remember that there's going to be a plus or minus solution unless they tell you you're only dealing with positives. Okay. But if you chose E, it's probably because you knew this rule. This is what the GMAT does. It's very mean. It makes you learn rules, and then it throws wrinkles that confuse you now that you know the rule. So if you knew the rule that, well, something squared is 64, that could be 8 or -8. You might have thought, well, hold up, x equals 66, the square root of 64, well, that could be 8 or -8. So that's not sufficient either. And together it's not sufficient, so I choose E. But in mathematic convention, this is actually only 8. We don't consider the negative in this situation. If you introduce the square root symbol, you need to consider negatives. That means since I have to do a square root here, since I introduce a square root in my mechanics, I need to consider the positive case and the negative case. If the square root is already there, you just take it as it is. So the answer to this problem is B. Even though in both situations we end up taking the square root of 64, in one of them it only means the positive case, and in another one you need to remember the positive and the negative case. Okay, so based on the answer choices here, that was a lesson we needed because I had a lot of D's and E's. I had some B's as well, for sure, but make sure you are clear when you need to that you need to sometimes consider positive and negative. Okay, those of you that chose D. Those of you that chose E, you don't always have to consider positive or negative. It depends on what you're given. Any questions about this one? Cool. Let's take a look here. Give you a minute and a half or so for this problem. Okay, I'm getting a lot of answers coming in. A lot of B's. Okay. Quick mental math. Do these subtractions here. If in your mental math you ended up at 188 or 45 or 46 or 473, I understand you have my sympathies because I do the same thing all the time, but that is a common mistake in quick subtraction. It looks like we did a pretty good job here on it overall. A lot of right answers here. I see some right answers here in the chat. So we did well on this one, but it is something I see all the time. If you set up this question here, you get 2x plus 66 equals 100. And I see a lot of people go 100 minus 66. Oh, that's 44. 2x equals 44, so x is 22. See a lot of people do mistakes like this when they do fast subtraction. But 2x, that 44, 100 minus 66 is not 44. And same thing over here, these 200 minus 22 is not 188, it's 178. 80 minus 45 is not 45, it's 35. Okay, what's happening when, because I did have a C or two pop up, and I didn't see a lot of answers in this one, but maybe someone made these mistakes, made this mistake. What's happening when this occurs? It's just a fast mental heuristic that's going on. We know that, okay, well, 10, this 0 is going to become a 10, so it's going to subtract to an 8, and then 20 minus 2 is 8. Like, that's easy. Right? I know that 120 minus 80 is 40, and then I'm going to have that 0 minus 4 is going to be 6, so I'm going to do 46. Okay, but that's not quite correct, because I'm adding a 6 when I shouldn't. I should actually subtract another 4. Okay, so I just, fast subtraction, whenever a multiple of 10 pops up, okay, just make sure you, it tends to be multiples of 10 that I notice this, numbers that end in 0. Okay, so just take a second, make sure you're not falling for a fast, for some reason it doesn't happen, 181 minus 45. People don't miss that as often as they would 180 minus 45. As soon as you get that 0, the temptation to move quickly just really, okay, 10 minus, that's gonna be 5, and 140, because 180 minus 40, okay, cool, 145. Nah, not quite. But it looks like we did well on that one. Okay. Let's take a look here. We'll save that. Yeah, we'll do it. Okay, this is, I'll admit, not the greatest example of what I'm trying to teach here, but it'll get the point across. Take a minute and watch, or take a minute and choose A or B for this problem here. All right, make your final guesses here. Brittany mentioned in the chat. A previous video we've done on fast math that I think is worth mentioning. Break the subtraction into pieces. Instead of doing 80 minus 45, do 80 minus 40 minus 5, and you're much less likely to make that mistake we're talking about, because then you'll end up with, okay, 40 minus 5 can't be 45, it's got to be 35. It's a good callback, Brittany. Thank you for mentioning that. So here we're about 50-50 on the split here. This is not, in my opinion, the best example I could find, or you could find, but in the making of these slides, it was the best one I came across for that was available. We're a little limited in which sentences we're allowed to use and whatnot due to copyright reasons. The answer to this one is A. There are two reasons why this is true, although I only mean to reference one of them. One of them is the parallelism. And I think I actually used this example in my parallelism video. We have a marker and joining two things. Well, what is being joined here? Am I trying to join banked and overlaid, things describing the framework of poles, or am I trying to join banked and, was banked and was conical, describing the house? And this is a tough question, but it seems fairly clear to me that what I'm trying to bank with dirt is the framework of poles, not the house itself. But that's kind of tough, I will admit. That's because they're both grammatically correct to say. The thing I want to talk about in this lesson, though, in this particular problem, is this split of to a height of 3 to 4 feet and as high as 3 to 4 feet. And the mistake I'm trying to address here is too generous in your linguistic interpretation in sentence correction. You are going to, because the GMAT tries to ensure it, understand what the sentence is trying to say. It's going to be pretty clear what the sentence is going for, what story the sentence is telling. But what that means sometimes is that you are going to let that understanding of what is attempting to be said overcloud what is actually said and what is actually there. And in many ways, this is testing how well you remain objective in the face of information, right? How well you let the objective facts tell you the story, or the objective facts speak for themselves, or do you let your subjective understanding overcloud what is objectively in front of you? I think that's what it's going for anyway. That's my assertion. But if we think about as high as 3 to 4 feet. What is as high as 3 to 4 feet? What in this situation is 3 to 4 feet high? So I have a few chats here that say dirt. So the dirt was 3 feet high. Is that what's 3 feet? Like, let's think about that. Is that what's 3 feet high? And this is getting a little pedantic, but welcome to the GMAT. I don't think dirt can be 3 feet high. I think what is 3 feet high is the embankment of dirt, the structure that is being built out of dirt. Dirt itself, like, what is 3 feet high dirt? I can have a 3 foot high pile of dirt. I can have a 3 foot high mound of dirt. I can have a 3 foot high embankment of dirt, but I can't have 3 foot high dirt, I would argue. But I do think that's what this is describing in the structure. It's saying the dirt is as high as 3 to 4 feet, when what I know is that there is an embankment of dirt that is 3 to 4 feet high. But that's not what this sentence says. This says dirt is 3 to 4 feet high. I don't think that quite makes sense. My subjective understanding might overlook that, but if I think about what structurally that means, it's saying dirt is 3 to 4 feet high. This right here, to a height, banked with dirt to a height of 3 to 4 feet, that's describing how high the dirt was banked, or how high these poles were banked with dirt. And so it's a different description that makes more sense. I can't describe the dirt as 3 to 4 feet high. Not really. D'Alessandro is asking, is there also a problem with as X as Y? I don't think so, except that it's describing the dirt, D'Alessandro. I think that's like the structure itself is okay. You can say as high as 3 feet. We built the wall as tall as 3 feet. I don't know if that's quite a good example. That might not quite make sense. But you can describe things as high as something. The house was as high as a mountain. But it doesn't make sense to call dirt as high as 3 feet, because dirt doesn't really have a height. A mound of dirt does. A pile of dirt does. Dirt itself does not. So be careful about letting your too generous interpretation overlook what's actually there in the structure. And I'll just warn you all, as you do this, you're undoubtedly, after you watch this lesson and start thinking about it, you're going to go too far sometimes. You're going to deconstruct, you're going to be too critical and say, like, well, that doesn't really make sense if I do what Reed talked about in that GMAT video. And if I get really specific and precise, it doesn't make sense to write this particular phrase. And then it's going to actually be okay, and you're going to be mad at me because it turns out it works in that situation. But my advice is try to get there. Try to overcorrect for a while. See how far you can go in this direction. And after you've realized you've gone too far, scale back a little bit. But most people don't go far enough to ever get there. Try to be more particular than you think you need to be. And eventually you can pull it back. Okay. Another common mistake, take 45 seconds a minute to simplify these expressions. Okay. So this page is meant to, oh, not that. Nope, not that either. I must not have made the right, there it is, addition. Okay, so this page is meant to be examples of addition, multiplication, and exponent mix-ups. Certain rules and certain mechanics apply to one of these three, and it's very tempting to cross up when you use which. So for instance, you might think, oh, 9x squared plus 16y squared square rooted is 4x or 3x plus 4y. That's not correct. There's really no simplifying. I kind of did an unfair trick here. There's really no simplifying you can do. This is not accurate. You can't just cancel out the perfect squares in this situation because this is added. If it were multiplied, if it was 9x squared times 16y squared, you could say 3x times 4y. Although if I'm being very technical, we'd have to know x is positive and y is positive to say that. Otherwise, you could say 3 times the absolute value of x times 4 times the absolute value of y, because y could be positive or negative as we saw earlier. But if we know they're positive, you could simplify this to 3x times 4y. But if it's added, when it's added, there's really no simplifying you can do like that. But the GMAT lays traps like this all the time. They're just begging you to split up a radical over an addition sign. But it just doesn't work. I mean, consider, what is the square root of 4 plus 9? Well, we know that's the square root of 13 because 4 plus 9 is 13. But if we try to use that, well, let's split it up. It's going to be 2 plus 3, which is 5. And is 13 square rooted 5? No. But this is definitely what we're doing here. So this move is not allowed. Okay. Don't split up a radical over addition and subtraction. Same thing with a fraction. You might think, oh, 5x on top and bottom. Cancel it out. Who cares? Not if it's added. You could do something here. You could say 20y over 5x plus 5x over 5x. So I guess you could simplify this one. Because 5x over 5x is 1, and 20y over 5y simplifies to 4y. So you could end up with 4y plus over x. You could end up with 4y over x plus 1. But you can't just cancel out the 5x and the 5x because it's not multiplied. It is added. Similarly here, you can't say that this is 9x squared plus 16y squared. That doesn't work. Can't distribute an exponent over addition. You can over multiplication. If it were 3x times 4y, you could. But this you got to FOIL out. This would be 9x squared plus 24xy plus 16y squared. Okay. Can't just distribute an exponent over addition or subtraction. Only multiplication, division. This one right here, you might be tempted to be like, okay, well, I remember this. I add my exponent, so this is going to be x to the 9th. Not in this case. That's if these are multiplied. If it was x squared times x cubed times x to the 4th, you could say it's x to the 9th, but not if they're added. There's really only one thing you can do if they're added, and that's factor out a common factor, which in this case probably would be x squared. And you could say I have x squared times 1 plus x squared. And if you factored it back or distributed it back through, you would see that these are the same using your exponent rule, but that's all you can do here. There's no adding the exponents in this case because it's not multiplied. This one's a little bit different, but negative x squared is negative x squared. That negative is not part of what gets squared. Negative x squared, if it's part of it, yeah, that equals x squared. But negative x squared is negative x squared. It does not become positive. Okay. Any questions I can answer about these? We're clear on the mix-up of multiplication and addition. These are the most common. There might be others, but these are the ones I see most frequently. Okay. Let's take a look. We're going to do, I don't think we've done a verb. No, we've done some sentence correction. Mating the answer to number 1, it's honestly, there's nothing you can do. It just stays what it is. There's no simplifying that can be done. Take a look at this critical reasoning. I'll give you a full 2 minutes for this one. All right, come up with a final guess here. See some answers in the chat. D seems to have the gravity, and D is the correct answer. Well done. So many cities in our nation pay higher salaries for bilingual workers than our city pays. Okay, well, what that starts to imply is that maybe we're going to offer these discounts to students who are going to learn a foreign language, but then they don't stick around to deal in the tourism industry. They don't have to work in the tourism industry, but to interact with tourists, to talk to tourists. And once that happens, once they don't stick around, this plan falls apart. They're gone. Okay, they took our discount and they left, and now we're, just in the place we were anyway. So that would weaken the argument if there was a reason to leave the city for another city. Once we've learned a language. D'Alessandro, so you're wondering how do we know students are motivated by salaries? We don't. And this is we're going to step outside of today's lesson for a second, but it is a good lesson in general. The GMAT critical reasoning is full of, I don't know, like blown feathers. What I mean by that is on a weakened question, the right answer is going to blow the feather in the direction of the argument is weaker than it was before. Now, it's possible that it's not ruined, right? So your point is like, well, what if students are not motivated by the higher salaries? What if they don't leave the city? That's possible. And then the argument would still be in play. But which way does this answer choice blow the feather, right? The first move that answer choice D does is, that's a good reason to leave the city. And maybe, maybe they don't care about salary, but if they do, this argument's weaker, and that's where the feather blows. And I don't want to blow it back. I don't want to be skeptical and blow it back. You want to be skeptical in general, but you are allowed to, you're not allowed to blow the feather in the opposite direction that the GMAT blows it, I guess is the way I can describe that. And so, yes, D doesn't ruin the argument. It's possible they don't care about salaries and that this argument is still okay and that, okay, it's not ruined. But at first puff, the argument's weaker. Okay. So that's why D is right and why you don't want to try to like negate why D. Don't negate why D weakens the argument, basically, right? If it weakens the argument, it weakens the argument. That doesn't mean it ruins the argument. The argument might be okay, but it doesn't weaken. It doesn't. I'm sorry. It doesn't. It definitely weakens the argument. Just because it doesn't ruin the argument doesn't mean it's not the answer. In fact, in general, you're not trying to ruin arguments. You're just trying to make them a little weaker. Same thing in strengthen. You're not trying to guarantee the argument. You're just trying to make it better. Now, the two traps on this this question that I want to talk about are A and B, and these are the ones that I did see some people choose, and people are asking about them now in the chat. So B is, I think, a very common wrong answer choice. But the fact is that it is totally irrelevant to the argument at hand. I have a plan to save tourism in this city. It's to offer discounts to our students, okay? To learn a foreign language that our tourists speak. That's my plan. You weaken the argument by weakening my plan. You don't weaken the argument by saying my plan is one of many plans. The fact that there might be another way to save tourism in my city doesn't mean my plan to save tourism is weakened. Okay, maybe we could recruit foreign language speakers from another city to work here. That doesn't mean my plan is weakened. My plan might still work fine. It's just an alternative plan. So alternative plans don't weaken arguments or strengthen arguments or affect arguments at all. Deal with the argument that they give you. Don't consider another argument. And this is an artifact of what we do in the real world, right? If someone gives you a plan, but it's not the best plan, your job is to go, well, hold up. there's a much better way to do this. You know, that's a very real world approach to problem solving. But in critical reasoning, we're not in the real world. We're in the world of reasoning. How well is the reasoning in this argument? How well can we really support that these discounts will save tourism? That's what I'm really curious about. If there's other things that'll save tourism, great. I'm not interested in that. I want to know, will these student discounts save tourism? How well is that reasoned out? And so B is just irrelevant. Similar issue with A. If people don't care about tourism, that doesn't mean offering discounts don't work. That's not really relevant to this. Yeah, okay, so it's not important concern for most people in the city. Okay, will the discounts save tourism or not? I don't care if saving tourism is important or not. Will offering these discounts save tourism? And you might say, well, hold up, if people don't care about tourism, then they're not going to offer the student discounts. That's not really what the GMAT, that's not how the GMAT plays. We don't want to doubt the premise, right? We're going to say, yeah, give them the discount. I don't think it means tourism is going to be saved because they'll move to another city once they learn the language, or they won't take the discount for whatever purpose, right? Like, there are other things that would ruin the argument. I don't want to say like, well, maybe we can't even offer the discount, so argument ruined. No, I want to know about the reasoning of the argument. How well reasoned is the argument? If we offer discounts to students for learning a foreign language, it will save tourism. That's the world I want to pick apart. So if there are other plans, I don't care. If people don't really care about my plan, that doesn't mean it's not going to work. Okay. And these are very, very common wrong answer choices in critical reasoning. Other plans or the why bother. You know, those don't really weaken an argument. They're not particularly relevant. Okay. Let's take, I'll give you all, under reading comp, let's see. Oh, I have so many more I want to do. We have about 10 minutes. Yeah, go ahead, take 3-4 minutes to read this passage and answer this question. And we'll talk about the trap answer here. just so you all know, if I were taking this test, I probably would have been reading until about now. It's okay to give yourself time to read these passages. I'd say, 2.5 minutes or so to read these paragraphs and understand what's going on. Too often I see people rush through reading comp. Okay, let's come up with a final guess here. This is a hard question, by the way. Four answers, four different letter choices. Always fun. Five answers, five different letter choices. Okay, so the correct answer to this question is A. Scientists have yet to formulate a definitive explanation for Henley's findings. And the structure of this passage is basically, okay, scientists for a while thought it was really hot due to friction down there. But then the scientist, Henley, they found out that we don't know. Or they found out that it's not that hot. The temperature is much less than we'd expect. And maybe it's because these rocks are weaker, or clay, maybe. But then another person tested and was like, well, but actually, when we put clay and stuff under pressure, it gets really hot and frictionful as well. So maybe it's water, right? That's kind of the structure of this passage. And so we have Henley's findings that say this temperature is not as hot as we expected. And we have a hypothesis of maybe why, but that hypothesis doesn't end up being true. Okay, and then there's another hypothesis given. So what does this passage say regarding Henley's findings? It's very tempting to say that I'm wondering if I'm answering this correctly. It's easy to say like, oh, well, we need to throw out the finding. We don't, like, it's wrong. Okay. Because it turned out that this didn't line up with what we'd expected. Okay, it doesn't say that it provides support for an assumption held by geologists, and we haven't tried to duplicate the findings. That's not the issue. Is not that Henley had some findings and that we haven't been able to duplicate those findings. It's that we haven't been able to explain those findings. The tempting confusion here is the confusion of why something is true or that something is true. And you want to be very careful about that. A lot of times they debate why something is true, or they wonder about the effects of why something, or the effects of an occurrence, right? Sometimes they'll say like, okay, A is true, and then they'll debate if A means B or if A means C. Well, a debate about B and C doesn't mean A is not true. Or if A is true, sometimes they'll talk about, well, maybe B causes A or C causes A. And a debate about B and C does not mean A isn't true. And so be very careful of the point of a passage. Okay, don't mix up the fact that something is true versus a question of why something is true. B is wrong because this is Hinyi. We don't have Hinyi's explanation. I realize I didn't talk about that for why this is true. We have some geologists wondered about frictionless stuff, but Hinyi never gives an explanation. Hinyi just says, "Here's the temperature." Why is C wrong in this case, particularly? Because Hinyi's findings should not be the point. This is what I mean. Hinyi's findings are not wrong. That's not, I mean, they might be, but that's not the point of this passage. The point of this passage doesn't say the measurements Hinyi got were wrong, so we need to recalculate them. Just because we can't explain why Hinyi's findings are true does not mean we need to recalculate those findings. They're still true. We just don't know why. That's why A is correct. So the fact that something, the confusion about why something is true doesn't mean we need to doubt that it is true. Sometimes we do, sometimes that will be the point, but that's not the point of this passage. We never say, oh, Hinyi's wrong. We just say, we don't understand why Hinyi seems to be right. Okay. Jay, you say on the last slide, what last slide? Which one were you talking about, Jay? A and B versus C. Oh, so that's, yeah, so that's this slide. Is that clear? Right, we're wondering why Hinyi's conclusion is true, but we don't doubt that Hinyi's conclusion is true, meaning the temperatures that Hinyi found, those are the temperatures we believe. Oh, I see. Okay, yeah. So I was saying that, okay, if I have an event A, and then I say, well, A is going to lead to B, and other people say, no, A is going to lead to C. If I'm debating this, if I'm debating whether or not B or C occurs or will occur or did occur, what have you, if I debate that, that's not the same thing as debating A. A is still true. What's in question is what A leads to. Here's the question. Where does A go? Does A go to B or does A go to C? It's not the same thing as saying A is not true. So don't confuse why something is true versus that. Don't confuse why something is true with that something is true. That's the idea here. Okay, friends, few more. We'll go a little bit long today because I only have a few slides left, and I want to get this whole lesson out. So you get a free GMAT hour and 10 minutes. Take a minute and a half for this problem here. Okay, I'm going to call it there. I'm getting a lot of right answers in the chat here. A lot of people saying D. D is correct. The trap here is the difference of percent, the difference between percent of and percent more or less. I'm told that some city grew by 1 million people, or some country grew by 1 million people, and another country grew by 300% more than that. 300% more than 1 million is 4 million. because that's 3 million more. And 3 million is 300% of 1 million. So 300% of 1 million added to the 1 million gives me 300% more than 1 million. This trap shows up all the time. You always want to be very specific. Am I dealing with a percent of something or a percent more or less than something? They're very related. You can go from one to the other, but if you cross them up in the setup, you're doomed. Very common trap. Very good. We did well on that one. Oh, do I want to do both of these? That might be tough. Yeah, let's take 3 minutes. See what you can do. For the sake of time, I'm going to wrap this up. If you were watching the recording and you need more time, go ahead and hit pause. This is definitely a little fast. So I'm seeing quite a few answers come in. It looks like A and A has the gravity, and that is correct. Okay, these are both meant to test how careful you are with inputs and outputs. And this is something that lurks throughout the test in general. You want to make sure you're clear on which is which you're asked about, which you need to answer for, etc. Okay. Here, if you chose C, and I saw a few C's in there, you chose the input for Y that gave you the least possible value of this thing. Yes, if Y is an integer, then 23 minus 25, where Y is 5, that's going to give me absolute value of -2. This doesn't get any smaller than that. That is 2. And so I plug in 5 to get that output. But the answer is not the input. The answer is the output, A. If you chose B, it's because you didn't consider that this might go negative, and you just thought Y equals 4. 23 minus 20 is 3, but I can go one smaller by going to -2. Okay. But don't mix up the number you put in to answer the question with the actual answer to the question. Same thing down here. I did have an E or 2 in the answer choices. That is the maximum in general, but I'm not asked for the maximum. I'm asking for the high 3 seconds after the maximum. Well, the maximum is going to be at t equals 25 because that makes this thing 0. So I subtract nothing from 40. 3 seconds after that is 28. But that's not the answer choice. I think we did a pretty good job avoiding D here. At 28 seconds, I'm 40 minus 27, because 3 squared times -3. So the answer is A, 13. So just keep track of your inputs and your outputs. Don't answer one when you mean the other. All right, friends, let's do the last question here. This will be, I suspect, a challenge, harder than some of the other ones we've done today. So I'll give you a full 2 minutes to solve it, and we will wrap this up. Okay, that's 2 minutes for the sake of time. I'm going to call it. Again, we're doing pretty good with this one, although we're fairly split between A and B, which is expected. Okay, so the error that tends to be made in questions like this is dealing with Y% and how to treat Y%. Whether you pick numbers in this case, which I think is maybe easier, or if you do algebra, either way, the same mistake can lead to a wrong answer choice. Okay, if I pick a percent, if I say, let's say Y is 20, this amount decreases by 20%. What do I plug in for Y in the answer choices? If you plug in 0.2, you're hosed. You're done before it starts. And I know why it's tempting to do so, right? I picked 20%, and 20% is 0.2. But you picked 20%. Your Y is 20. And when I take that Y, that 20, and then I make it a percent, that's when I go to 0.2. But this is not Y. This is Y. And so I want to plug in 20 for Y. And same thing if you set up an equation and you said, okay, well, a Y% decrease is 1 minus Y times X. And then I add back that $1,000. And that sets me up, and then I end up at Z. Great. Well, what you've done is you've turned Y into a fraction. And yes, you can go, like with numbers, you can go from fractions to percents to decimals and back again. But with variables, Y% as a fraction has to be Y%. If you just make it Y, you're doing the fraction Y, not the percent Y. And this is not quite right. If you did this, you should have been confused by this 100, I think. You should have had a 1, but a lot of people will be like, well, it's pretty close, so I guess A. But that's not correct. The answer here is B. And it all hinges on this variable percent, okay? When you pick a variable percent, you plug in y% for y when you picked y for y%. I had fun with that label, right? But you pick y, 20, but then you plug in 20% into the answer choices or into the equation you build. That's not how it works. Okay, keep track of the difference between y% and y itself, which you then take a percent. You turn into a percent. Very, 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 very common mistake on questions like this. I see it all the time when questions like this pop up. I wanted to take a second to specify it. Okay, everybody. That's what she wrote. Check out our upcoming courses at that link. You can reach out to me as well with any questions or concerns about the GMAT Prep, or our services. Happy to answer any questions. I'll stick around now for those that are live and wrap this up, but I can't stay too long. I actually got a class starting at 8 o'clock tonight. So maybe I'll see somebody there. Otherwise, be good, be well, best of luck in your studies. See you next time.